Skyscrapers are undoubtedly one of the greatest triumphs of modern engineering. Lightning, on the other hand, is one of Mother Nature's most common and destructive forces. So when paired against one another, they make pretty good adversaries. Lucky for us, there are safety measures put in place to protect our tallest buildings from lightning strikes. An average lightning bolt can carry up to 300 million volts of energy and travel at a rate of around 270,000 miles per hour. Despite these numbers, 9 out of 10 people who are struck by lightning end up surviving. The real threat lightning poses is to our systems and infrastructure. In 1977, a series of 3 lightning strikes caused a 25-hour blackout across nearly all of New York. Then there's the risk of damage to our buildings, particularly skyscrapers, our tallest buildings. They are a lot more susceptible to lightning strikes than the average building. For instance, the Empire State Building is struck by lightning about 25 times a year. Without proper protection, this would lead to a catastrophic amount of damage. When striking an unprotected building, lightning will find other conductors to travel through, including its phone cables, electrical systems, and networking systems. Thankfully, skyscrapers come with lightning protection systems, or LPS. Contrary to popular belief, lightning does strike the same place twice. Adding to this threat, lightning can even strike multiple buildings at once. It's actually a good thing that it does. If we were unable to direct the point struck by lightning, then LPS would be severely limited in its effectiveness. Most tall buildings come equipped with several components to their lightning protection systems. Air termination systems catch incoming lightning bolts. Conductor systems redirect the current. Earth terminating systems send this current safely into the ground, where it can dissipate. Let's start with the air termination system. Perhaps the most iconic iteration of this would be the lightning rod. While engineers have been incorporating lightning rods into their building designs since the 18th century, it wasn't until Benjamin Franklin's famous kite experiment that these rods were deliberately used as a way to minimize damage to a structure. So how do lightning rods work? Lightning rods are made of conductive metals such as copper or aluminum. They come in a large variety of designs to suit different needs. Some modern lightning rods feature multiple rods connected to one primary mast. Others try a bit harder to draw lightning towards them. For example, the tip of the Burj Khalifa emits positive charges, which attract the negative ions found in storm clouds that create lightning. A series of advanced sensors detect these negatively charged clouds and signal the LPS to release its charge. As these ions are thrown out, a bolt of lightning is generated from the LPS to meet oncoming lightning. It's only fitting that the tallest building in the world has an equally state-of-the-art lightning protection system. Regardless of their design or features, all lightning rods function the same way. They serve as a terminal for lightning bolts to pass through, allowing the current to be directed along a safe path. To help facilitate this function, they are often placed at the highest point of a skyscraper to encourage lightning to strike at this specific point. It's crucial that lightning strikes here, as the rods are connected to a series of conductor cables laid out along the tops and around the edges of roofs. These conductor cables make up the down conductor system. Current from a lightning bolt then travels down to a building's ground cables in the earth terminating system. These cables run along a building's edges all the way underground, where the current can be safely displaced. With buildings getting taller and taller and nature growing increasingly unpredictable, it is clear that lightning protection systems are needed now more than ever. Thankfully, as our skyscrapers grow more advanced in their construction, so too do their lightning protection systems.